Scientists discovered something Atlantis-like near Australia. There used to be an entire continent that's now underwater. Here's what happened to it. Around 70,000 years ago, during the last ice age, there was a huge landmass called Sahul. It was located in the southwestern Pacific Ocean. This ancient supercontinent connected what we now know as Australia, New Guinea, Tasmania, and the Aru Islands into one giant piece of land. Imagine lush tropical rainforests surrounded by beautiful mountains. Sahul's tallest mountains were in the New Guinea highlands, with peaks reaching over 13,000 feet. This beautiful place was home to a variety of unique animals, most of which were pouched creatures. But back then, they weren't just koalas and kangaroos. Sahul was filled with different types of grazers, burrowers, scavengers, and predators. It was home to a huge diprotodon, a powerful hunter Thiosolio, and a horrifying Megalania, a creature that's much larger than any living lizard today. It was a unique place because the rest of the world was filled with placental animals at the time, like wolves, elephants, and humans. In Sahul, the only normal mammals were bats and rodents. But not all its parts were the same. The Timor, Arafura, and Carpentaria regions were covered by hot savanna and dry forests. It looked kinda like modern Australia, hot air deserts with scrubland, steppe, and temperate forests along the eastern coast. Back then, people were migrating all across the world. They made an incredible journey from Southeast Asia to Sahul and first arrived here from 60 to 45,000 years ago. They mostly traveled by foot and crossed the sea using bamboo rafts and simple boats. They came there from an ancient landmass called Sunda, which includes parts of Southeast Asia. They traveled across a series of islands known as Wallachia and eventually spread across Sahul. And it wasn't a small journey. Sahul was huge, around 4.1 million square miles. That's bigger than the USA or Canada. It stretched from the equator to around the southern part of New Zealand. So they arrived in what is now Australia and became Australia's first people. Scientists think that Sahul had a population of 500,000. We've discovered cave paintings that date back around 40,000 years. It's a hunting scene depicting an anoa, or miniature buffalo, facing figures of humans and animals. Researchers are trying to figure out how these early settlers moved across Sahul and where we might find archaeological evidence of their journey. To do this, they created a landscape evolution model. The simulation showed how Sahul changed between 75,000 and 35,000 years ago. It showed potential migration routes and archaeological sites. Humans likely traveled along coastlines and rivers. But how did Sahul get submerged off the coast of Australia, similar to the mythical Atlantis? During the last ice age, much of the Earth's water was locked up in large ice sheets and glaciers. The sea levels were much lower than they are today. After that, the global temperatures increased. The ice sheets melted and the sea levels rose, flooding the land bridges that once connected different parts of Sahul together. About 8,000 years ago, New Guinea separated from mainland Australia, and then, about 6,000 years ago, Tasmania did the same. We still can explore the underwater parts of Sahul thanks to new technology. Divers explore and collect samples directly from the ocean floor. Underwater drones can go to places that are too deep or dangerous for humans to explore. And with sonar mapping, scientists use sound waves to create maps of the ocean floor. It's like using an echo to see what's underwater. The sound waves bounce off the seabed and come back, helping us create a picture of what it looks like. Deep underwater, archaeologists have found stone tools and other artifacts. They also discovered fossils of animals like Diprotodon and Thylasolio. By studying the underwater terrain of Sahul, they learned about the ancient rivers, lakes, and coastlines that existed during the Ice Age. But Sahul isn't the only underwater continent. Sahul isn't the only hidden gem of Southeast Asia. Take Sundaland, a place made up of Sumatra, Java, Borneo, and some other islands. This place was crazy huge during the Ice Age, but now almost fully underwater. Almost, but not entirely. The parts above the ocean are teeming with life. If you like birds, check this place out. It has almost a fifth of the world's bird species. You can spot colorful birds like the Java hawk eagle and the Bali starling among the lush forests. It's also a home to a fourth of Earth's fish species. Sundaland's waters are a haven for marine life, even the most exotic animals like the Asian arowanas. It's also a treasure trove of flowers. That's where you can find Rafflesia and Titan arum, the world's largest flowers. This makes it very similar to Zealandia. Zealandia is a long, narrow piece of land about half the size of Australia. It broke from Antarctica about 100 million years ago. Just like Sundaland, it isn't fully underwater. 7% of it stayed above sea level. This sticking out little piece is what we now call New Zealand, along with Stewart Island and some smaller islands. These pieces of Zealandia are lush and warm. They're packed with volcanoes, mountain ranges, beautiful natural geysers, and hot springs. Local people, Maori, use these hot springs for cooking. People place corn, eggs, and vegetables in baskets and lower them directly in the hot springs. Sometimes they cook food in a pit oven using heated rocks. Another hidden world is known as Argoland. This mysterious landmass was once part of Australia, back when dinosaurs chilled around. It drove scientists crazy for decades. They knew it existed because it left a huge stretch on the ancient seafloor, the Argo Abyssal Plain. About 155 million years ago, it broke off from Australia, saying bye-bye. The continent drifted somewhere north, and when it reached Southeast Asia, it just vanished. Scientists had no idea where it went, but recently, they finally found its remains. Turns out, poor Argoland's lower parts started drowning into the Sunda Trench, a horrifyingly deep oceanic pit. The Earth's crust sunk into the mantle. Meanwhile, the upper parts of Argoland were pushed upward, grabbing the younger rocks on land. Because of this, Argoland broke apart into a bunch of smaller pieces. These pieces formed parts of Borneo, Java, Sulawesi, and other regions. The remains are buried under Indonesia and Myanmar. Imagine a colossal landmass the size of Greenland, Greater Adria. Its journey began about 240 million years ago when it broke away from the supercontinent Gondwana. It started moving north, and after 100 million years of enjoying the warm seas, it suddenly crashed into Europe and shattered into pieces. Most of these pieces went deep into the Earth's mantle, but some were scraped off and became part of mountain ranges like the Alps. Today, the remnants of Greater Adria are scattered across more than 30 countries, from Spain to Iran. That's why they're hard to look for. Seychelles was also once part of Gondwana. Yep, these idyllic islands are sitting atop of the ancient continent. We know a lot about it because of its fascinating granite outcrops. 100 years ago, Alfred Wegener discovered continental drift, but no one believed him. These granite outcrops helped him prove that he's not crazy and that tectonic plates really are moving. The Seychelles broke off from India and Madagascar and eventually became a sad loner in the Indian Ocean. This probably happened because of some insanely active volcanoes in the Deccan Traps. But now, the islands are home to unique species both on land and in the coral reefs nearby. Mauritius broke off from India after the dinosaur wiping. Along its journey, it stretched into a long ribbon-like shape and also broke into pieces. Now it's all scattered beneath the Indian Ocean. Scientists stumbled upon this lost land by studying tiny ancient crystals called zircons. These zircons are like time capsules. They date back an astonishing 660 million to 2 billion years. That's even older than Mauritius itself. These ancient crystals hinted that there's another Atlantis somewhere nearby. Turns out there are hidden continents all around the world, and maybe we'll discover more of them in the future.
The Azores are 9 islands in the Atlantic Ocean, sitting about a third of the way from Europe to North America. A history textbook will tell you that the Portuguese explorers discovered this beautiful archipelago in the 15th century. Until then, they were uninhabited. The island still belonged to Portugal, so there seems to be no controversy or mystery here, except for the fact that some researchers think the Azores were home to an ancient civilization from thousands of years ago. Others support the idea that the famous Atlantis itself was here. In 2010, archaeologists announced that they found some structures on the islands which looked like they were from the Stone Age. If that's true, it would mean that there was a civilization back then which was advanced enough to travel this far and settle on the remote islands. A special scientific commission studied the matter and concluded that those structures were natural rock formations or had a more modern origin. So the first settlers were supposed to have been the Portuguese. It didn't stop some enthusiastic scientists from further research. They analyzed the DNA of mice from the Azores and found that it had the same genetic characteristics as house mice from Northern Europe. The little rodents couldn't have sailed this far without humans, so it looks like the first people had arrived at the Azores before the Portuguese. And the plot thickens. Dr. Felix Rodriguez, who works at the University of the Azores, is determined to find out exactly when it happened. He's studying the megalithic structures found in the Azores. Similar structures found in Western Europe and the Mediterranean date back to the Neolithic age. According to Dr. Rodriguez, the oldest findings are from 4,200 years ago. It's not clear when civilizations left them. The professor identified 7 megalithic structures in one complex as dolmens for the deceased. The cavities are all cylindrical in shape and definitely don't look like a natural formation. The material from the cavities turned out to be at least 2,500 years old. There are also some pieces of ceramics that seem to be even older. It looks like the rocks in the area had been lifted. You can see it by the small waves left by lava. It's thick and sticky, so it can't leave vertical marks. Someone must have moved the rock from its horizontal position. Another interesting finding is some stone anchors with holes found by the sea. Similar ones were used in the Mediterranean and on the Atlantic coast of Europe, dating back to 1000 and 2000 BCE. The 15th century Portuguese were advanced sailors and never used stone anchors, only metal ones. The scientists also managed to find a structure built right in the volcanic top. It looks somewhat similar to the ones built in the Mediterranean that are at least 2,000 years old. These structures are called columbariums and were used to store the ashes of the deceased. They also found something resembling an oven next to it, so they could be a part of one complex. There's also a basin in the middle, and it's not the only one on the island. It looks like they had a special meaning to their builders. There are channels around the construction. They connect the 4 basins, and the sun lights each of them at different times of the year. It was all carefully planned, as they were lit the brightest during winter and summer solstices and autumn and spring equinoxes. The water passed through all the basins and went directly into the sea. It could have been a purifying ritual. Now, some people are skeptical about the findings and believe they're all parts of a fortress from the 16th century. Professor Rodriguez is determined to prove it's all much, much older. There must have been some ancient civilization here that could have left because of the volcanoes that go crazy every 50 years. Antonietta Costa, a postdoctoral student at the University of Porto in Portugal, is also sure that the first people came to the Azores in prehistoric times. She has studied standing stones with small openings, explained as cuts for quarrying the stones. Costa believes they are part of a calendar system. She noticed that none of the slits in the rocks were aligned with the cardinal east direction. The slits closest to it are smaller than the ones facing other directions, so it can't be just a coincidence. It also looks like the slits are aligned with the solstices, and that's what makes Costa think it could be a calendar. She also thinks the inscriptions left on slabs of bedrock on the islands are much like those maps that were left on the rocks during the Stone Age in mainland Europe. Another interesting theory about the Azores is that it could have been the location of the famous Atlantis, which was lost under the sea. Since the Azores archipelago is in the middle of an ocean, it could technically be a perfect place for that. A 20th century scholar quoted Plato to prove this theory was right. The Greek philosopher suggested that Atlantis was in between the continents. The coins and sculptures supposedly found in the Azores when the Portuguese just arrived also point that there was someone else present there. And way more recently, in 2013, a sailor found a huge structure looking like a pyramid off the Azores coast. It was most likely a large submarine volcano, but it's much cooler to think it was some big deal in Atlantis, right? Peru has its own mystery. Amid the desert, you can find some eerie marks called the Nazca lines. They're known as geoglyphs and were created more than 2,000 years ago by the people of the Nazca culture. Thanks to a dry climate and strong winds in the desert, most of the Nazca lines have reached our day. To create them, Nazca people removed the top layer of the pebbles and revealed the soil beneath the ground. The color of the soil changes from reddish-brown to yellowish-gray, so the lines always look different. Most of the geoglyphs depict plants and animals. You can clearly see a monkey, a whale, a condor, a hummingbird, a spider, various flowers, trees, and other plants. There are also some geometric shapes, such as triangles, trapezoids, and spirals. Since they were discovered in the 1920s, scientists have offered different explanations for the lines. Some say that in Nazca culture, people ascribe special significance to these motifs, so they probably created these shapes for deities in the sky to see. Others believe they were a sort of astronomical calendar, and animal sketches were modeled after groups of stars. This theory was proved wrong, so the purpose of the lines remains a mystery. Another place that leaves many questions is Nimrut Mountain in Turkey. This mountain has a complex of monuments with temples and tombs. It was built by the Kingdom of Commagene, which ruled here around the 1st century BCE. There are statues of King Antiochus, 2 lions, 2 eagles, Zeus, Hercules, and Apollo. Archaeologists found the ruins of this complex at the end of the 19th century. They thought it had been built by the Assyrians. Then, some of the most famous scientists of the time came here and found an inscription in Greek. It had details about the sculptures and the names of important members of the Commagene royal family. It looked like it had been put there for future visitors. The scientists established that the statues used to be full-size figures. Changes in temperature, strong winds, snow, and the bright sun didn't leave them a chance to last in all their original glory. Plus, the complex is in an earthquake zone, so all you can see now is mostly the heads of the statues. They look incredibly complex and large for their time. The biggest question is, how did the people who lived thousands of years ago manage to create such huge sculptures on top of the mountain? It's obvious that they worked on shaping the limestone blocks up there and not on the ground. So, stay tuned. We'll keep an eye on this. Surprise! There's more than 7 continents on our planet. Argoland, a hidden continent, may help us understand how our planet will look in the future. To find out how it hid from us and what secrets it holds, well, you'll just have to keep watching. Ready for a mystery? Scientists have been looking for a piece of land that's been missing for over 100 million years. Not exactly newsworthy, since people search for information about our planet's history all the time. You'd think it was probably this minuscule island somewhere in the middle of an ocean. Well, you'd be wrong, because this continent used to be as big as the entire U.S. territory. For a long time, geologists have been wondering whether a massive chunk of contemporary Australia vanished into thin air. Some believed it was simply hiding somewhere on the ocean floor. But thanks to some Dutch specialists and 7 years of investigating, we now know there are bits and pieces of this lost land mixed underneath the lush jungles of Southeast Asia. The continents we see in our geography manuals these days are like scattered pieces of a puzzle. There's even a nice experiment you can conduct to see for yourself. Find a world map online and print it out. Cut out all of the continents and play around with them for a while. You'll see they all fit together. Probably the most striking thing you'll see is how South America perfectly fits near Africa. If you close up the oceans that were formed in the last 200 million years, the continents look like they form a giant letter C. And that C is what scientists call the supercontinent Pangaea. It was swimming in an ocean called Panthalassa. And the inner portion of that letter C had a smaller stretch of water called the Tethys Ocean. It is in this small ocean where things get interesting. Back in the Jurassic period, this vanished continent, which scientists started calling Argoland, vanished and left a hole in Australia, now known as the Argo-Abyssal Plain. Geologists initially believed this was all due to a process called subduction. It's when one piece of the Earth's crust dives under another and recycles it into the planet's mantle. Usually, specialists track this continental vanishing through off-scraping. That's how they figured out, for instance, that India bumped into Asia and gave us the majestic Himalayan mountains. But for Argoland, things were a bit more complicated. Bits and pieces were popping up in places like Myanmar and Indonesia, but they behaved like these time-traveling relics, looking way older than when Argoland supposedly separated from Australia. It immediately raised the question, if one continent can behave so weirdly, how many others are out there doing the same? Thankfully, scientists have now put together the entire timeline of Argoland and figured out its mystery. It didn't sink or get swallowed up. It simply transformed into an archipelago, breaking into smaller pieces, called microcontinents, and floating away from Australia. These mini-continents then took a little journey before settling down in Southeast Asian jungles. This discovery fits right into the whole Pangea puzzle. It helps us better understand how continents break up and make up, all in one discovery, revealing secrets of biodiversity and climate back from in the day. If you'd like to find out more secrets about history, civilization, or random day-to-day objects, be sure to like this video and subscribe to the channel. Like, for instance, the mystery behind this invisible species line in Indonesia. It's called the Wallace Line, named after the British explorer Alfred Russel Wallace. Over 150 years ago, Wallace was on a journey around the Malay archipelago, visiting thousands of islands. What he found was that animals on one side of this invisible line were considerably different from ones on the other side. This invisible line is like a wall between marsupials and tigers, for instance, or honey-eaters and trogons. But now we know that around 35 million years ago, Australia broke up with Antarctica and collided with Asia, and this continental love triangle triggered significant changes. It didn't just change the way the land looked, it also messed with the species of animals on each side of the Wallace Line. In more recent times, a bunch of specialists published a study saying this collision and climate chaos made Asian species comfy living in the Malay archipelago. Meanwhile, the Aussie animals weren't as happy with the new environment. It was too hot and wet for some, and others just couldn't handle the tropical island lifestyle. The discovery of this continental shift towards Asia might also explain a recent finding of a human species that didn't seem to make any sense either. You see, in this hidden cave in the Philippines, archaeologists stumbled upon a new human ancestor. It seems that about 50,000 years ago, on the island of Luzon, there was this ancient human-like species. The lead researcher believed this finding was crucial for understanding human evolution in Asia, and it named this new species after the island, Homo luzonensis. Now, here's where it gets a bit confusing. The bones found by archaeologists had one small problem. They had a weird mix of traits that hadn't been seen together in any other hominid species. Smaller teeth, similar to ours, yet hands and feet that were more like our ancient humanoid ancestors. It was those throwback limbs in particular that connected this human species with the long-lost Southern Territory. That's because they have this primitive look, like these hard-to-pronounce guys, for instance. Only these two species are separated by 2 to 3 million years of time in evolution. Many have wondered, is Homo luzonensis really a new species? Not everyone is convinced. But it may also explain why living creatures are also affected by the constant shifting of the land underneath us. Now, just because they haven't changed much during our lifetime, it doesn't mean our continents will look like this forever. They evolved from this large megacontinent, and they'll most likely end up in a similar position in the future. On that note, a geologist from a European university tried to predict the future of Earth's supercontinents. As a starting point, he used an earthquake that occurred in Portugal back in 1755, when tectonic plates behaved a bit differently than they should have. After years of research, he came up with a theory in 2016. He believed that the stitches between these tectonic plates might be coming apart, setting the stage for a bigger rupture. It's like when glass cracks between two holes in a car windshield. If this happens, a subduction zone could stretch from the Mediterranean all the way up past Ireland, bringing volcanoes, earthquakes, and new mountains to these areas. If all goes according to this plan, the Atlantic Ocean will disappear, and so will the Pacific, turning into one large stretch of water. Instead of the 7 continents we know today, we'll get a new supercontinent, which he called Arica, because it would have Australia and the Americas at its heart. Now, it's not the only possible scenario, though. Novo Pangea might be another, and it's easy to foresee. The Atlantic stays open and the Pacific closes. Then there's Amasia. For this one, you'd have to imagine the Arctic Ocean closing and the Atlantic and Pacific staying open. Everything shifts to the north around the North Pole, except Antarctica. One final scenario would be called Pangea Ultima. Slow down the spreading in the Atlantic, and a new subduction plate pops up on the America's east coast. Well, either way, if all the continents collide in the future once more, some say it won't be fun to experience. It's believed that in around 250 million years, we'll feel like we're being trapped in a sweltering, soggy plastic bag. Weirdly, that bag will be the best place to live on Earth, the coastal areas. As for the inland spots, they'll be sizzling, like a desert on fire. Many of the species of animals we know today might not make it. As for us humans, we'll need to be creative if we want to withstand the heat. We should be thankful, though. These digital models are still great because we can use them to test all sorts of interesting ideas. For example, how these supercontinents would mess with tides. Taking future space travels into consideration, these models can help us understand the climates of exoplanets too. Those are located outside our solar system. Do you know how many continents there are on Earth? That's an easy one, 7. But wait a second, aren't Europe and Asia one large continent, Eurasia? It looks so when you look at the world map. Well, scientists think differently. They don't just look at bodies of land sticking out of the sea. Geoscientists study the types of rock that continents are made from. When you see the world from their perspective, the number of continents actually increases. Yes, they are not a myth. Lost continents exist, or at least they used to. They are hiding under other land masses. Peekaboo! Researchers have recently discovered one continent just like that. It's called Greater Adria. Sound familiar? Yes, it has something to do with the Adriatic Sea. This lost continent is completely buried under Europe. It collided with Europe and started to sink under it a long time ago. Today, it lies beneath Italy, Greece, and the Baltics. Its size and even shape match that of Greenland, the world's largest island. But how did geoscientists find Greater Adria? It's no longer visible, but it left some clues. Parts of it were embedded in the Alps. Other chunks were incorporated into present-day Italy and Croatia, on the other side of the Adriatic Sea. Limestone rocks from the former continent started to change once they were under the European landmass. Tremendous heat and pressure spread over tens of millions of years changed their structure. Out goes the limestone, in comes the marble. All the Greek and Roman temples you admired on your summer vacation were constructed using this marble. It was sort of a going-away gift from a long-lost continent. Greater Adria camouflaged itself well for thousands of years, but other lost continents were hiding in plain sight. Have you heard of Earth's 8th continent, Zealandia? Probably not, because it sits under the surface of the Pacific Ocean. 95% of Zealandia is now underwater. Can you guess where exactly? Its name is a good hint – under New Zealand. If you open Google Maps, you can see its outline. Look for a lighter shade of blue in the ocean. It should stretch from New Caledonia to New Zealand. This bump in the ocean floor used to be above sea level. It was about 2/3 of Australia and more than twice the landmass of Greater Adria in size. We can spot Zealandia today because it hasn't sunk too low. And that's the best way to discover other lost continents. Imagine the Earth without the oceans. The bottom of the sea isn't flat. There are mountains and trenches. You could put Mount Everest in the deepest of them, and there would still be 7,000 feet between it and sea level. This trench got so deep because of a geological process called subduction. The Pacific Plate got under the Philippine Plate. Earth's crust is made out of those plates that float in a sea of molten rock. Then they bump into each other, one goes down while the other one rises. That's how Greater Adria ended up under the European continent. Our planet is constantly on the go. We don't notice this process because it happens deep beneath our feet. 120 million years ago, Australia and Antarctica were a single piece of land. Yep, the coldest and one of the hottest places on Earth were once the same territory. Antarctica said goodbye to Australia, but it didn't leave empty-handed. Today, there is an oceanic plateau in the Indian Ocean. The word plateau comes from French, and it means elevated flatland. And the name of this land sounds like the title of a Hollywood movie, Broken Ridge. Long ago, it was connected to another lost continent. Scientists believe that it made a land bridge between India and Antarctica. What was this land like? The answer possibly lies in a tiny archipelago in the southern Indian Ocean. These islands are all that is left of an ancient landmass. They have a cold climate. The islands feature glaciers because they're so close to Antarctica. But in the past, the climate must have been temperate with plenty of rainfall. The animals and plants would have been similar to those that we find in tropical regions today. The lost continent's landscape probably resembled that of New Zealand. Now, while we're in the area, can you guess which continent the island state of Madagascar once belonged to? If you guessed Africa, sorry, you were wrong. Hey, don't feel bad. Look up and to the right of the map. The correct answer is India. Some 120 million years ago, I wasn't around then, India separated from the African continent and went northeast. Madagascar wasn't quick enough and ended up as an island off the southeast coast of Africa. But there is evidence of an even greater landmass, the lost continent of Mauritius. Scientists found traces of the ancient landmass under the island of Mauritius. Today, it's a tourist hotspot, but millions of years ago, it was a real hotspot, volcanoes and all. That's how scientists were able to retrace the steps of Mauritius. They found a mineral that exists in rocks which lava spews out after an eruption. The long-lost land once covered the area from Mauritius to the west coast of India. Imagine if that land existed today. It would form a great mix of Indian and African cultures. The local dishes would definitely be spicy. Now, speaking of spicy, have you had Indonesian food recently? Just 50,000 years ago, Southeast Asia looked much different. There was no Sumatra, Borneo, Java, or even Australia. Just Sunda and Saul, two continental masses that were divided by a deep water trench. You had the extension of mainland Southeast Asia on one side and the Greater Australia on the other. Back then, Bali stood at the southernmost tip of Asia. Biologists were among the first scientists to notice the split. Species develop differently on Sunda and Sahul. That's why Australia has unique animals, such as the kangaroo, wombat, and platypus. And did you know that a giant kangaroo once roamed the island of New Guinea? That's because, up until the end of the last age, there was a land bridge to Australia. Today, the two islands are separated by the Torres Strait, but it's quite shallow, less than 65 feet. It's a reminder that this was once a single landmass called Saul. Another ocean strait that isn't too deep separates Asia from North America. The Bering Strait sits today in the place of Beringia. This ancient landmass wasn't that big. It stretched 1,000 miles from north to south. That's just a third of the driving distance from Los Angeles to New York. Beringia was important for another reason. During the Ice Ages, it connected the whole world. Water levels were 300 feet lower than they are today. If they went even lower, you could walk from the Cape of Good Hope in Africa all the way to Cape Horn in South America. Talk about the ultimate backpacking route. Today, you can hop on an airplane and fly to pretty much any place on the globe. The world has never seemed smaller, has it? Well, it has. Some 300 to 200 million years ago, we were all one world, literally. Pangaea was a supercontinent that included all of the continents. Its name is in Greek, and it simply means all Earth. But Pangaea started to crack up. The biggest gap formed between the Americas on one side and Europe and Africa on the other. Seawater soon started pouring in, and that's how we got the Atlantic Ocean. This process is by no means over. While you are watching this video, North America is drifting further and further away from Europe at the rate of 1 inch per year. Doesn't seem much when compared to the average human lifespan, but in the end, all the continents will reconnect with each other, forming a supercontinent. And it wouldn't be the first time in Earth history that this happens. Honestly, I'm not going to wait around for that. Hey, quick question. How many continents are there? 7? Maybe 5? There's no correct answer. According to different approaches, the range is between 4 to 7. But it might actually be as many as 8. Chances are, a lost continent has recently been found between Greenland and Canada. This new continent discovery could also potentially be the key to how microcontinents form. What does this all mean, and what makes this hidden landmass near Greenland so important? Now, if you're like me, and if you are, then there's 2 of us, when you hear the word continent, you probably think of land like Europe or Africa, places above water where people live. But in science, a continent isn't about being above sea level. It's about what the land is made of. Earth's outer layer, called the crust, comes in 2 main types, continental and oceanic. Continental one is thicker, lighter, and made of different types of rock, like granite. The oceanic crust is thinner, heavier, and made mostly of dark volcanic rock. Now, the discovery under the Davis Strait between Greenland and Canada appears to be a piece of continental landmass, even though it's under the ocean. Scientists call it a proto-microcontinent because it began to break off from a larger terrain millions of years ago, but never quite made it. As tectonic plates slowly shifted, the Earth's crust in this region stretched and cracked. One chunk started to split away, but for some reason, the process stopped. It didn't drift off like a full continent, and it didn't sink like ocean crust either. Instead, it stayed right there, floating beneath the waves all this time. This makes it different from true microcontinents, like Zealandia, which have completely detached and now exist as separate tectonic blocks. Zealandia is a submerged microcontinent near New Zealand. About 94% of it lies underwater, but because it's made of continental crust, many geologists say it qualifies as Earth's 8th continent. However, Zealandia is still debated because it's too big to be a microcontinent, and there's no official global body to define its status. There's no global organization like the UN or some kind of international geology council that can declare, hey, this is a new continent. Unlike Madagascar, which is fully above sea level and widely accepted by geologists as a classic example of a microcontinent, Zealandia is still waiting for a proper label. I know you're probably wondering, isn't Madagascar an island? The simple answer is, it's both. It's the 4th largest island in the world, completely surrounded by water. But it's also geologically considered a microcontinent because it broke off from the supercontinent Gondwana around 88 million years ago and is made of continental crust, not oceanic crust. Unlike volcanic islands like Hawaii, this isn't just built from lava. It's a real piece of ancient continental crust. So, Madagascar checks both boxes: island by geography, microcontinent by geology. And that's exactly why these discoveries can be fascinating. Just like Madagascar stands out above the waves, this newly discovered landmass under the Davis Strait stands out beneath them, thanks to its unusual structure. What makes it stand out is its unusual thickness. Most of the ocean floor is thin, like metal. This is more like packed clay, layered with continental materials. Underneath this cozy comforter, scientists discovered some odd layers of rock, unusual because they're not where they should be. These layers act more like the materials found on continents rather than those typically seen on ocean floors. There are hints of granite-like formations and distinct magnetic properties, which suggest that this stuff is similar to what makes up dry land. The size is also remarkable. The proto-microcontinent is about 12 to 15 miles across, which makes it roughly the size of a mid-sized city, like Manhattan Island at 6,500 feet underwater. The fact that it sits right under the Davis Strait, one of the widest ocean passages on Earth, makes it one of the largest submerged continental fragments we've found. According to researchers, this landmass began to form between 58 and 49 million years ago, when Greenland and Canada were slowly drifting apart. Maybe they just weren't getting along. Hey, it happens. As they pulled apart, the crust under the Davis Strait stretched, and one of the main fault lines shifted. But the breakup didn't finish. Around 48 million years ago, the rifting stalled, and Greenland's motion away from Canada slowed dramatically, when it later bumped into Ellesmere Island. It's like a car swerving off and then back onto the freeway, a turn that was never completed. That's basically what happened. A chunk of land got stuck between the motion. It didn't float off into the ocean like a new continent, and it didn't get pulled down into the Earth either. It just stayed where it was, stranded beneath the water. But that's not all. This chunk has its own fault system, and scientists say it actually looks like a miniature version of the San Andreas Fault in California. Now, a fault is basically a crack in the Earth's crust where sections of rock slide past each other. Think of it as a place where the Earth's surface split and tried to slide sideways. In California, this movement still happens today and can cause earthquakes. But under the Davis Strait, it's a different story. The movement started, then suddenly stopped, like hitting pause in the middle of a big shift. It's a frozen moment in the planet's past, preserved right beneath the waves. For geologists, that makes the microcontinent under Davis Strait incredibly valuable. That sudden pause in motion helps explain why some chunks of land break away cleanly, while others twist, stall, or disappear. But this isn't just academic. By studying how continents break apart or stall, scientists can better predict future shifts in land, fault lines, and seismic activity. And predicting earthquakes and geological hazards could prove quite valuable to everyone. Knowing how microcontinents form could help us anticipate how the planet's surface might shift over millions of years, which affects everything from climate models to resource availability. But even just the technological advancement needed for such discoveries is greatly beneficial. The same tools used to map this hidden land are used for oil exploration, laying undersea cables, climate monitoring, and even search and rescue missions. Speaking of technology, for a long time, this hidden landmass near Greenland remained invisible. Just 10 or 15 years ago, the ocean floor under the Davis Strait was basically a mystery. It's deep, almost frozen, obviously not the easiest place to explore. But today, thanks to modern tools, a new continent discovery could be just a matter of time. Scientists can finally see and hear what's going on under all that water. First, they use seismic reflection imaging. That's a method where ships send sound waves down to the ocean floor and record how they bounce back. Various layers of rock reflect sounds in different ways, which helps build a picture of what's hidden underneath. It's kind of like how bats use echoes to see in the dark. Satellites also play a role in collecting gravity data. This may sound strange, but different types of rocks have slightly different weights. Heavier rocks create stronger gravitational pull, and satellites can measure those tiny differences. Another tool commonly used for these explorations is underwater sensors, which sit quietly on the seafloor and listen for natural vibrations, like mini earthquakes or shifts in rock. These vibrations help scientists figure out what the crust is made of and how thick it is. They're basically ears on the ocean floor. They also most likely used AUVs, or autonomous underwater vehicles, basically robot submarines that can scan the seafloor in high resolution, even under thick ice. In any case, scientists are very excited because this new continent discovery is more than just a geological surprise. It's what they call a natural laboratory. The study of the microcontinent Davis Strait offers a rare opportunity to understand how microcontinents form, evolve, and sometimes fail to fully separate. It also reminds us that Earth's crust isn't as neatly divided as we once thought. Beneath the ocean, there may be other hidden landmasses near Greenland or elsewhere, almost continents, just waiting to be found. This lost continent of Canada may not have made it as a fully fledged landmass, but its discovery is already reshaping how we view plate tectonics. And thanks to advances in technology, places we once ignored are now offering up secrets about the planet's deep past, and maybe even its future. Now, history teaches us that the supercontinent existed a long time ago, around 300 to 273 million years back. At that time, all the continents on Earth were buddies and hanging out together. They formed an amazing crew called Pangaea, or Pangaea if you're feeling fancy. The name comes from a Greek word which means all the Earth. Pangaea also had a massive water neighbor called Panthalassa. So our entire world was a huge piece of land surrounded by a huge piece of ocean. The megacontinent looked like a giant sea, stretching between the tippy top and bottom of our planet. But as stories go, things change. About 200 million years ago, in the early Jurassic epoch, like dinosaur times, Pangaea decided to throw a breakaway party. Forget about the old ideas of continents just drifting around like big icebergs. It split up into smaller chunks, forming the continents we know today. Oh, and it created the Atlantic and Indian Oceans as a bonus. Pangaea's tale was first told by a German weather expert named Alfred Wegener in 1912. But how did he learn about something that happened so long ago? Imagine the Earth's core as a big, cozy fireplace, giving off heat. This heat creates special swirling currents in the Earth's outer shell. We can think of it as the Earth's crust, which looks like a big puzzle with many puzzle pieces. The hot currents make these puzzle pieces, called crustal plates, move around. Sometimes they push apart, sometimes they crash into each other, and sometimes they slide past one another. It's like a fantastic dance party that goes on beneath our feet. One day, Wegener looked at the shapes of the continents and thought that, hey, those coastlines of South America and Africa kind of fit together. And they really did. So he imagined that way back, all of the continents hung out together as one big landmass. But he couldn't just go and say that without any proof. So, how do we know Pangaea really was a thing? Well, there are some clues that brought us to this amazing discovery. One clue is like when you put a puzzle together and the pieces fit just right. Take a look at the shapes of today's continents. You'll notice that they could fit together almost like a perfect match. Obviously, their shapes changed over time. It happened millions of years ago, and since then, the shores of continents have been washed by waters for years. But even so, we can still see how well they fit together. Another clue comes from checking out fossils. We know that ancient animals left a lot of fossils behind. That's how we learn their history and what species there were. But when scientists compared fossils found on different continents, they found something interesting. These fossils look similar. Surprisingly, they belong to the same groups of animals, even though they were far apart. It's not like these animals could swim across the ocean on their four paws. And it's unlikely that this particular type of animal originated in two places at the same time. And finally, the mountains. Imagine exploring underwater and finding huge mountains in the oceans. These underwater ranges and deep trenches are like scars from when Earth's tectonic plates moved around. They serve as another proof that the continents are part of something bigger. When you look at these things together, you get a pretty clear picture. The Earth's continents were once huddled together in the supercontinent. They've since gone their separate ways, but the memories of their grand adventure are still written in the shapes of coastlines, the rocks they left behind, and many more. But it's obvious to us now. At the time of Wegener's discovery, there were different ideas flying around. Some folks thought that the continents sank down to make the oceans, but Wegener had a different take. He thought that the continents are always on the move. He even came up with a fancy phrase, continental drift, to explain it. Later, he was joined by another scientist named Alexander Dutoit. He added a little twist to the story, suggesting there were two original continents, Laurasia in the north and Gondwana in the south. But the real party didn't start until the 1960s, when scientists figure out the secret ingredient in this recipe – plate tectonics. And finally, this theory explained everything Wegener and Du Toit talked about. Wegener's theory was proven correct after 50 years. As time passed, we learned more and more about our planet. We found out that the Earth used to have multiple supercontinents. Before Pangaea, there was a megacontinent called Rodinia around 1 billion years ago. And later on, Pannotia joined the scene about 600 million years ago. What's interesting is that the continental drift story is far from over. Our continents are always on the move. Africa is giving Europe a friendly bump, and Australia is playing a game of bumper cars with Southeast Asia. You know what's on the horizon? Another supercontinent. So, how will this next supercontinent come together? Well, there are 4 major possibilities: Novo Pangaea, Pangaea Ultima, Orica, and Amasia. These might sound like superhero names, but they're actually ways the puzzle pieces could fit. Let's look at them all. First, Novo Pangaea. You know how there's the Atlantic Ocean on one side and the Pacific Ocean on the other? Well, if these oceans keep doing what they're doing now, the Atlantic will keep opening up while the Pacific squeezes in. If that happens, the Americas, North and South America, will give each other a big high five. And Antarctica, that icy land way down south, will join the fun too. It'll be drifting northward. Next, Pangaea Ultima. In the future, the Atlantic Ocean might get tired of being so wide. It might decide to slow down and shrink a bit. The Americas and the northward drifting Antarctica will probably crash into Africa and Europe. And just like that, a brand new supercontinent forms. There are these spots where the ocean floor is sliding underneath the land. It's like a secret underwater passage. These spots are called subduction zones. So if these secret tunnels will be spreading and spreading all along the east coast of the Americas. The Americas, Europe, and Africa might come together again, and they'd form a supercontinent. This supercontinent would be surrounded by the Pacific Ocean. The next possible supercontinent is Orica. In this scenario, the Pacific and Atlantic Oceans might decide to take a nap and close up. But don't worry, because when one door closes, another opens. In this case, a whole new ocean would pop up to replace them. Imagine a big crack in the ground cutting through Asia, like a zipper opening up. This crack is called the Pan-Asian Rift, and it would become a brand new ocean. With this new ocean comes a new supercontinent, Orica. Australia is currently drifting northwards, like it's trying to find a nice spot at the center of our planet. East Asia and the Americas might join in from both sides. After that, Europe and Africa might link up with the Americas, and boom, Orica. And finally, Amasia. It might form if some of the tectonic plates go north. They can take continents like Africa and Australia along for the ride. They'll be hanging out around the North Pole. All the continents except Antarctica might come together. And even though they might gather around the North Pole, they won't close off the oceans. The Atlantic and Pacific Oceans would still be open for business. How this grand reunion happens depends on the Earth's tectonic movements. So far, we believe that Novo Pangaea is the most likely scenario. It also depends on what exactly happened to Pangaea after it broke apart. And when the new supercontinent appears, what's going to happen with the weather? How will the ocean behave? And what about the animals and plants? These questions all light up our minds. Who knows? Maybe someday our descendants will look at the world map and see this incredible journey come full circle. So keep asking curious questions and stay tuned for the next 100 million years.
Around 3 to 200 million years ago, all the continents were stuck together as one big landmass. Over time, they moved apart and formed the continents we have today. That giant landmass was called Pangaea, and the Earth looked very different back then. Which begs the question, what would our life be like if that split never occurred? Well, let's find out. In simple words, tectonic plates are big chunks of the Earth's outer shell. Our planet is like a puzzle of landmass, and these plates are the pieces. Since the Earth is so incredibly hot inside, its heat influences the rocky ground above the core. Slightly melted rocks start floating in the ocean of scorched magma. This movement creates the tectonic plates, and they're always moving, just really slowly, which is why we don't notice it. Their movement has been a fundamental force shaping the Earth's surface, climate, and the evolution of life over millions of years. For example, when two plates bump into each other, one might go under the other. Or they might slide past each other. Sometimes they pull apart. All these movements create things like earthquakes and volcanoes. And when plates push against each other, it can make the land go up, creating mountains. So, the big mountain ranges on Earth, like the Himalayas, formed because tectonic plates were pushing into each other. Now, here's the thing with Pangaea. In a supercontinent, all tectonic plates are united, and they don't really move. Well, at least not a lot like they do now. So, if Pangaea remained intact for billions of years, everything in our world would look completely different. For example, we wouldn't have many mountain ranges anymore. No Alps, Himalayas, and Andes. What a nightmare that would be for ski lovers. But there's an upside to that too. No continental drift means much less disasters in our world. All our earthquakes, tsunamis, and volcanic eruptions would be much rarer and calmer, or might not occur at all. However, hurricanes would keep existing, and they could be crazy strong. With Pangaea being one huge lump of land, the rest of the world will be water stretching from the west to east. That's just a free water slide for a hurricane. Please feel free to build up in intensity without anything to bump into. So once it finally reaches us, prepare for Category 5 or even stronger hurricanes or tornadoes. They'd be regular visitors too. And if you decided to live in eastern Pangaea, yep, you're doomed. The way the continents are arranged also affects how the oceans move and the weather behaves. In Pangaea, the climate would be very different across the globe. The middle of our supercontinent would be super weird. Right in the center, we'd have a huge dry desert. But there would also be dense, cool rainforests along the borders of this desert. Why? Because Pangaea is so massive and rain from the ocean wouldn't reach far enough inland, so it would be stacking up around the edge. This would make some parts of the land not so great for anything. Rain and water would wear down the land, flattening hills and carrying away soil over a long time. Eventually, Pangaea might even shrink and disappear underwater. Closer to the edges of Pangaea, the weather might be more mild or tropical. Up north, it would be warmer than it is now. And finally, we'd have some understanding of seasons, but we'd have no idea that it becomes harder for you to breathe as you go higher. So, how would all this affect living things? Well, bad. Pangaea would be awful for the variety of life on Earth. History shows that having separate pieces of land is very important for life. It was a big reason why new kinds of species appeared. For example, Madagascar, an island that broke off from Pangaea, was isolated for millions of years, which is why it has many plants and animals not found anywhere else. Fewer isolated lands like Madagascar and Australia mean less cool and unique plants and animals. The climate problem doesn't go away either. Almost all Pangaea would be hot and dry inside, but it wouldn't be all too boring. There would still be some environments for animals to live in. Reptiles like dinosaurs might do well in this kind of climate. That's one reason why dinosaurs thrived when the whole world was one big landmass before mammals came around. Also, this might push for the development of creatures that can live in water. They'd be more diverse and bigger in size. So basically, Pangaea is a master of creating Earth as dangerous for humans as possible. With all this in mind, let's finally see how humanity's doing, assuming that we survived and evolved. First of all, where would your country be located? In theory, you could take a road trip from Brazil to Canada because they'd be part of the same huge landmass. North America would be right here, and Europe would be just east of it. Most of Asia would be up north, and Antarctica would stay down south. Australia would still be in the middle of nowhere. A literal Antarctica would be closer to everyone than Australia. That's assuming that countries stayed the same. And hey, cool news! All our modern countries might not exist at all. Okay, that didn't sound as good as intended. More precisely, the countries would have completely different boundaries, and the world would be much more peaceful and united. Let's see. First, we'd form some tribes. But since we would share the land, we'd have to compromise. We can't all have the only coast or only inland regions. Each tribe would probably get a fair piece of the land so that everyone could meet in the middle to settle problems or make trade agreements. As tribes got bigger, people would move to new lands, separated by deserts and forests, forming their own nations. The hunter-gatherer era might take some more time, since we have fewer animals and plants. If we started hunting, we'd probably wipe out all the big animals pretty quickly. Except for the ones we could potentially domesticate. Imagine having dinosaurs as pets! But the whole supercontinent would quickly enter the agricultural era, because whatever technologies we discover, we'd share them with each other right away. The main difference would be that during our age of exploration, there would be mostly small, isolated islands to discover. Travel and trade would be easier too. Cultures would be less distant from each other compared to our world. For example, right now, Native American culture is very different from Pacific Island culture because they've been separated by water for a long time. But on Pangaea, cultures might form a continuous line from the southern tip to the northern tip, which means all cultures would be very closely related. And that wouldn't be the only similarity. Our appearances would be very much alike as well. Since Earth is still tilted on its axis, the very north and south will stay cooler. So even though some people would still have white skin and blonde hair, in general, everyone would still have less melanin. Around the central part where the sun is always shining, most people will still have dark or tanned skin. This could create a more similar world where people could see themselves as global citizens and Earthlings. The sad part is, we probably wouldn't be as motivated for technological progress as we are now. All the land is already known. There's no need to explore. The weather is mostly good and warm. The crops are growing well, the neighbors are hopefully peaceful, which is why humans would be fine with things as they are. We'd probably stick to basic tools and science. Of course, we're naturally curious creatures, so we'd still have some progress. It just would be very slow compared to our world. What sounds boring for some might sound awesome for us. Our life would be less exciting, but we'd be more united and peaceful. Maybe, in a world like that, we learn to treat each other with more kindness and love. But we can only imagine.
Scientists claim that Icelandia was a region between Greenland and Scandinavia that was more than 230,000 square miles, but is now underwater. The Earth was once a large pizza pie, with all the continents connected to each other millions of years ago, otherwise known as Pangaea. The North Atlantic region we know today was dry land from about 335 million to 175 million years ago. For many years, scientists and geologists assumed that the North Atlantic Ocean was birthed as Pangaea began to split apart roughly 200 million years ago. With volcanoes in the region where Iceland is, the country came to be just 60 million years ago as it broke off and sailed away from all the other lands. And since the Earth was like a large pizza pie, it divided like one. Many of the lands split up into many large and small pieces, creating the continents we know today. But this new theory suggests that the result of Pangaea's splitting left out some land that stretched for around 200 miles. And just about 10 million years ago, that piece of land submerged in the waters on the eastern and western side, leaving the tip of the land, which is now Iceland. When plate tectonics move, they grind on each other, which gave shape to our current landscape, all thanks to the mantle. This new radical theory goes against everything written in history books and what scientists have been studying. They began shaking heads, drawing lots of skepticism and criticism. But by analyzing the ocean floor under Iceland and the Earth's crust, we can assume that this idea isn't far-fetched. The crust beneath Iceland happens to be a lot thicker than the typical ones. Oceanic crust is made up of unique melted rocks compared to the land crusts where we walk and live on, and is a lot more denser. The thinnest layer on Earth is the crust, where life takes place. It's essential for water, growing food, gathering natural resources and minerals, and breathing in oxygen. It sinks below to the bottom, but right above the Earth's mantle. It also refreshes itself, since it constantly gets recycled into the mantle and back up. This is why the rocks in the oceanic crust are around 25 miles thick, compared to just 5 miles anywhere else. This is also reasonable given that it's in a hotspot for volcanoes. Magnetic surveys of the ocean floor show layers of molten crust in stripe patterns. Also, given the fact that the Earth's magnetic field changed its polarity over millions of years, it played a role in shaping the foundation of our landscape. But there isn't any concrete evidence to prove this new theory just yet. One of the first steps is to start digging the ocean floor near Iceland. Zircon is a very sturdy mineral that can last for billions of years despite erosion in the Earth's crust. By taking samples and studying them, researchers can estimate the geological age of the continents. This will make sure the crust is oceanic, which is thicker, or continental, which is the regular crust we walk on. This isn't an overnight project and would come with a hefty cost. Another way is to do seismic surveys that can measure echoes conducted on research ships. Drilling holes miles deep in the crust can also help with the research. But this would cost more than studying the zircon minerals. Some fossilized plants unique to both Scandinavia and Greenland might prove that Icelandia was once on the surface and possibly scattered with trees. It wasn't a cold land as it is today, so it may have had forests. But scientists still haven't found fossil evidence of animals common in both lands to suggest anything. But maybe time will tell. The theory goes deeper, which suggests that there was a greater Icelandia. With Iceland, Ireland, Britain, Scandinavia, and Greenland all in one microcontinent, it could be a destination of winter enthusiasts and great for skiing. It could be possible to connect Canada to Greater Icelandia by train over the ocean, which would open up the economy even more. Iceland is around 40,000 square miles, which is already quite big. And if the Greater Icelandia was present today, then Europe would be a completely different continent. Many theories are circulating about other possible hidden microcontinents around the world. Scientists aren't certain of the possibility of Icelandia's existence, but if all the studies conducted were done correctly, then the theory could change everything we know about Iceland and the North Atlantic Ocean. And this could pave the way for other sunken microcontinents around the world. Another theory out there is that New Zealand was the tip of a lost subcontinent, even bigger than Icelandia, called Zealandia. Studies show that it's separated from the supercontinent Gondwana between 79 to 83 million years ago. Scientists claim that it's the thinnest and youngest continent discovered underwater. Craton is a core rock that acts as the main foundation for most continents. It's at least 1 billion years old, but the continental crust that makes up Zealandia is just half of that, which makes it quite young. That means some craton is missing, even though it holds some leftovers of older rocks and parts of the mantle. They're estimated to be as old as 2.7 billion years old. Scientists did some studies on the zircon crystals from New Zealand and found out that they're as old as 1.3 billion years old. The rest of the continents are more than 3 billion years old. Scientists studied the composition of the rocks in the bottom of the ocean around New Zealand. They're made up of silica and granite, which are found in continental crusts. The ocean floors mainly have magnesium and iron-rich rocks. They're also thicker and higher than regular ocean crusts around it. They conducted some studies and collected magnetic and topographic data to see the link between the Tasman and Coral Seas in the Cato Trough region. This is the narrow strip between Zealandia and Australia. Satellite data tracked tiny faults in the Earth's gravity to map out the crust of the ocean floor surrounding the area. They saw the mass that makes up Zealandia quite visible and almost the size of Australia. Even though the signs are there, this doesn't prove anything. It's possible that there are a bunch of microcontinents which all split apart when Australia broke free of Gondwana. Back then, the supercontinent was made up of South America, Antarctica, Australia, Zealandia, Arabia, and the Indian subcontinent. New Zealand is already not the biggest country out there, but if the theories are correct, then Zealandia will be 6 times its original size. Mauritius is a young island that's only a few million years old. Just 1,200 miles off the coast of Africa, it's believed that the tiny island came to life around 9 million years ago. The underwater volcanoes in the region spewed out so much lava that it formed the land today. But scientists found zircon rocks that are more than 3 billion years old. It may also be part of a continent submerged underwater called Mauritia, which is just a quarter of the size of Madagascar. The zircons they found were embedded in solid rocks and not just in the sand, which may rule out that they just washed up on shore from another continent. Some scientists are still not convinced. They suggest that discovering rocks that stand out from the other typical ones brought by an eruption could skew the scientific community to this theory. But just like how Icelandia could be part of Greater Icelandia, Mauritia was once called Rodinia, which consisted of India and Madagascar. Theories suggest that Mauritia was covered in water when India broke away from Madagascar, something like 85 million years ago.
Now, at first glance, it seems like we're on a giant raft called a continent that's just floating around on some molten lava until it hits another continent. Okay, let's make a quick stop at high school science class. Our home planet is like a cake with different layers of ingredients stacked up on top of each other. The Earth's core, mantle, and crust. Hey, where's the frosting? The cake batter on top represents the crust of the Earth, made up of 3 types of tasty rock: igneous, sedimentary, and, say it with me, metamorphic. These rocks are formed in different ways, such as from solidified lava or from the deposits of particles and minerals. The crust is what we stand on, a home to our continents, oceans, and everything we see around us. Then you have the mantle, not the baseball player, the layer that lies right below the crust. Many people think that the mantle is just lava, but it's not quite like that. Just like how you mix different ingredients in the cake batter, the mantle is made up of different types of rocks that are constantly moving and shifting. And finally, we get to the sweetest part of the cake, the center, or in the case of Earth, the core. It has 2 parts, the outer and inner core. The outer core is made of molten rocks and metals that are incredibly hot. Ow! Even hotter than the surface of the sun. The inner core is solid, even though temperatures there are crazy. It doesn't turn into liquid because the pressure down there is amazingly strong. When you see all this, you can easily think that below us there are endless miles of lava and hot rocks. So, how come tectonic plates move at all? The continents don't float on a sea of molten rock. The oceanic and continental crusts really sit on a mantle. Sure, there's a layer of liquid rock in our planet, the outer core, around 1,800 miles below the surface, but it's separated from the surface by the mantle that's thick and solid. So, the Earth's tectonic plates move around because they're on a thick layer of solid rock, the upper mantle. Basically, this rock is under incredible pressure and heat, which makes it flow in slow motion over time. Think of it like honey or syrup that you pour over your cake layers. As you move the cake around, the honey or syrup will also move and flow. Similarly, the upper mantle can flow and drag the parts above it along, just way slower than honey. And the rock is both breakable and flexible. It can crack and break like a cookie, now I'm getting hungry, but it can also stretch and bend like a piece of taffy. When the plates get caught on each other, they can't move anymore, but when they break free, they start drifting again, like puzzle pieces shifting around until they find their perfect fit. Extremely high temperatures and pressure are the reason this flow happens. It's like a big pot of soup on the stove. As the soup heats up, it starts to move around, carrying heat from one spot to another. Is it lunchtime? And speaking of lava, it's not just molten rocks that travel all the way up from the outer core to volcanoes. When tectonic plates come together and one slides underneath the other, they create a lot of heat and pressure while grinding against each other. It's like rubbing your hands together fast and they start to get hot, or when you start a fire with rocks. And as the melted rock, or magma, rises to the surface, it can create volcanoes. Now, long ago, the Earth's land was not divided into continents as it is today. Instead, there was one giant landmass known as Pangaea, meaning all Earth in Greek. Whoa! Imagine being stuck in the middle of this giant ocean. So, over time, this supercontinent slowly broke apart. Its parts drifted away from each other and formed the separate lands we call continents. This idea first popped out in the 16th century when one cartographer realized the coastlines of Africa, America, and Europe appear like they could fit together like puzzle pieces. Later, researchers realized the rock composition of their coastlines was similar, which means they used to be part of one giant mass, and they call that the theory of continental drift. At first, people were pretty skeptical about that idea because they didn't know how such massive lands could move around. Now, we'd all be able to explain that part, right? So, the Earth's crust is divided into a couple of large plates and many smaller ones. All of them are still moving, even though it's in slow motion. We can't sense it, and we won't see any particular changes during our lifetime. It's a process that lasts hundreds of millions of years. As the plates move, they interact with one another in fascinating ways. For example, when two plates collide, one may be forced beneath the other, which would help create a subduction zone. Over time, this is the way you get many cool things like volcanic islands, trenches, and even entire mountain ranges. Plates apparently started moving around 3.5 billion years ago. It took them a while to group into the first jigsaw supercontinent we know about called Ur. Today, its remains make up parts of Madagascar, India, and Australia. Pangaea formed 335 million years ago, but it probably won't be the last continent that will form. So, some new generations in the distant future could live on something called the next Pangaea. When the oceanic crust of the Atlantic Ocean slowly takes its place under the continental crust, the oceanic basin of the Atlantic is going to close, which is why the continents will end up pulled together. This means the Americas will meet Africa, and Eurasia will be flipped on its side. So people might live on a giant landmass in the shape of a ring, clustered around the inner sea, or at least what's left of it. Or maybe continents will take another direction and make up a different jigsaw puzzle called Amasia. In this scenario, the Americans will drift westward, fuse with Australia, and pivot to around Siberia. And then there's more. Novo-Pangaea is the option where the Americas swing together to embrace Antarctica and Australia, and Africa legs off to the northwest. Basically, all continents here get together to form a giant landmass that stretches from one pole to the other. Ready for one more? Nah, come on. A recent projection called Eureka gives an idea similar to Novo-Pangaea. It's just that all continents here unite to become one gigantic land that clusters around the equator. Maybe this would be my favorite one to live at, with the sunny weather and the beach all the time. And who knows what kind of magnificent trenches, mountains, islands, and other geological beauties we'd get with this giant supercontinent. Pangaea broke up about 175 million years ago. As the Atlantic and Indian Oceans began to widen towards the east, the Ring of Fire was formed. It's a path that goes along the Pacific Ocean with so many frequent earthquakes and active volcanoes. This way, Eurasia was unable to cross this border and continue moving westward. And now Eurasia could move laterally along the Ring of Fire. The subduction zones kind of act like a barrier that forces the tectonic plates to move in different directions. So Eurasia could eventually collide with the Americas and form something similar to Amasia. It would be cool to sit there, grab the popcorn, and watch it from the side. But this is something that won't happen for the next 50 million years at least. I'm willing to bet I probably won't be here to see it. Different theories talk about different positions where this new supercontinent might end up one day. But it seems it will probably be somewhere in the polar area, centered on what we today recognize as the Arctic Ocean. Not my cup of tea. Bring me back the sunny one. Wait, scratch that. Let's go eat. The lost city of Atlantis may have actually been found. No, really. Two researchers were working in the waters off the coast of Cuba when they discovered the ruins of what looked like an ancient submerged city. That happened about 20 years ago, and yet no one really talks about it today. It's like the authorities just took the research, locked it away in some top-secret room, and decided no one else should know about it. But why? Well, I'm going to tell you. Back in 2001, Paulina Zalitsky, a marine engineer, and her husband, Paul Weinswig, were hired to explore the waters off Cuba's western coast. They had two main objectives: to search for old shipwrecks, possibly hiding treasures like gold and jewels, and to locate valuable oil and natural gas deposits deep underwater. They were using a sonar. Basically, this equipment is like a sound-based radar. It sends out sound waves underwater, and when those waves hit something, like a sunken ship, they bounce back. The system can figure out where and how far the object is just by listening to the echo. So, the couple was scanning the seafloor with this equipment more than 2,000 feet below the surface. And then, out of nowhere, they found something way more interesting than gold or oil. They found stones. Not just any stones. I'm talking huge, perfectly arranged stones. Kind of like a mini version of the pyramid at Chichen Itza, or even better, like a bunch of tiny submerged Chichen Itzas. Yep, they saw that, or at least they think they did. The thing is, sonar doesn't work like a camera. It definitely doesn't record video or take actual pictures underwater. What it does do is create images using sound. And those images are usually just outlines or shapes, kind of like a blurry black and white sketch. It shows you where things are, but not exactly what they look like. And that's exactly what happened back then. The equipment started producing images of these perfectly organized stone structures, and it really looked like some kind of urban development. I mean, the site was just too organized, too symmetrical to be just random rocks. But it sounded too good to be true. I mean, this discovery could totally change everything we know about ancient civilizations on the American continent. So the scientists decided it would be too irresponsible to announce anything without finding more evidence first. And that's why they decided to go back to that same spot. This time they sent down an underwater remotely operated vehicle to actually see what was going on beneath the sea. See? This robot was basically an underwater cameraman. And yep, it confirmed it. There was definitely something strange down there. It looked like an ancient city made of huge, smooth blocks of granite. These rocks were about 8 feet by 10 feet. Some were in pyramid shapes, others were circular. Some seemed to be deliberately cut and then stacked on top of each other, while others appeared isolated from the rest. Together, they looked like they were forming corridors and outlines of rooms. It was like finding large buildings in the middle of an underwater desert. These images were enough for Zalitsky to seal the deal. Back then, she confirmed that this amazing structure, her words, could have been a large urban center. Again, her words. Then the couple started to speculate. They said that these structures were probably built more than 6,000 years ago. which would make them older than the Great Pyramids of Egypt. It's even older than the famous Maya, the civilization that used to live in the Americas and is known for their ancient and advanced temples. The research also suggested that these structures might belong to a civilization that lived on the American continent thousands of years ago, and that we didn't even know about. This supposed civilization once thrived on a 100-mile land bridge connecting Cuba to Mexico's Yucatan Peninsula. But then, something catastrophic happened. According to their theory, the Earth's faults shifted beneath the surface, leading to a massive earthquake. Then, in the blink of an eye, the entire bridge was destroyed. The land was swallowed up by the sea and ended up at the bottom of the ocean, and this civilization disappeared. Of course, all the connections to the famous Atlantis myth got the media totally hooked on the story. News websites ran headlines like "Lost City of the Caribbean Found" and "Atlantis Found in Cuba." So, could that really be Atlantis? I mean, did they finally find the remains of this supposedly super advanced and lost civilization? Well, it's hard to say. From the start, part of the scientific community wasn't buying into the story too much. First, there's the issue of the date. Saying that this civilization existed at this spot at least 6,000 years ago just wasn't very credible. Then, some European archaeologists argued that the stones they found using sonar might just be natural limestone, not perfectly sculpted granite. And third, it was too deep. Even with the whole theory of earth faults opening up and swallowing everything, it's still hard to explain how an entire city ended up so deep in the ocean. For comparison, there is Heraklion, a real ancient Egyptian port city that got submerged. Today, it is only about 19 feet underwater. But this so-called Atlantis city is at depths between 2,000 and 2,460 feet. See how that's totally different, right? People think it would have taken around 50,000 years for such stone structures to sink to the depth where they are said to be found. And according to experts, none of the known civilizations from that long ago had the ability to build such structures. But for Zalitsky, yes, it was possible. She still believed in the fault theory to explain how this land ended up at the bottom of the ocean so fast. Big movements of the Earth's tectonic plates are usually followed by things like volcanoes and earthquakes. So, according to her, it's a powerful event, and the island sinking could have happened really quickly. This earthquake theory could also explain why some of the megaliths on the seafloor look organized while others don't. But to really prove any of this, they needed a specially designed robot to go down there again and take samples of the rocks and sediment. That way, they could figure out how old the rocks were and maybe even find signs of human life, like carvings, sculptures, or artifacts. The problem is, drilling into those structures isn't easy. They look like granite, and drilling granite that deep underwater is seriously tough. And more than anything, they needed money to do it, a lot of it. So maybe they just never got the funding. Because even with all that initial hype, no further explorations or studies were ever reported. And that lack of follow-up sparked a lot of speculation. Some people even wondered if the story got shut down on purpose, like maybe the authorities wanted to keep something top secret. As if this underwater city was built by some kind of higher extraterrestrial being, and they just don't want us to find out. But truth be told, the strongest argument for saying, yeah, that is definitely a lost city, is that nature supposedly couldn't have built something so symmetrical. Geologists did try to find natural explanations, or at least similar examples from other parts of the world, but they came up short. Still, just because we haven't found a clear natural explanation doesn't mean there isn't one. Nature can create some pretty wild and unexpected stuff, so honestly, that whole too perfect to be natural angle is kind of a weak argument. What most likely happened is that experts just weren't convinced it was actually a sunken city, and that's probably why no one followed up on their work. Over time, the buzz faded, the story disappeared, and the site slipped back into silence. And without more data, the true nature of those underwater formations off Cuba's coast is still a mystery.
Ever since Plato wrote about the allegory of Atlantis, humanity has been fascinated with the possibility of the discovery of a thriving underwater civilization. Fancy joining me on a trip to a few historic underwater sites? Let's see what we can find out about ancient civilizations. The first one on our list is what is being called the underwater Stonehenge. Scientists have recently discovered a mysterious pile of cairns that stretch for miles under the shimmering waters of Lake Constance at the borders of Switzerland, Germany, and Austria. Archaeologists began to explore the site back in 2015, and they haven't been able to understand yet what it was actually used for. What they do know is that there is a 12-mile line of 170 human-made stone cairns under Lake Constance. Scientists say this was most likely the result of a combined work of several villages. The cairn site was probably used for some collective purpose. The formations are huge. Some of them are several dozen feet wide. The most amazing discovery so far is that the site dates back to around 5,500 years ago. Now, what were we humans doing back then? We were living in the prime years of the so-called Stone Age. We were beginning to make artifacts from stone and use them to hunt and eat. Can you imagine what a knife and fork might have looked like back in those days? It's no coincidence that scientists call this site the underwater Stonehenge, though. Both sites are believed to have been built around the same period of time. You see, Stonehenge dates back to around 3100 BCE. Both sites carry the distinct characteristic of stone monuments built in a circle. Not to mention the fact that scientists also haven't figured out why on earth our early ancestors would feel the need to build a monument such as Stonehenge. Well, the mystery of Lake Constance hasn't been solved yet. Who were the Neolithic people from this area? And for what purpose did they go through such an amount of work and effort to build this huge stone site? Next, we're taking you on a tour of the Ryukyu Islands just off the coast of Japan. You're diving deep down to an archaeological site. But I should warn you, the waters of the Pacific Ocean are far from smooth. It doesn't take long before you see a huge structure, thanks to the sunlight shining down on the seabed. At first, it looks like Machu Picchu's ruins located across the globe in Peru. As you approach the site, you slowly figure out its forms. A pyramid-shaped structure, arches, staircases. It's something that could have easily been a palace or a castle. Could this be a sign of human activity? What you've just seen is known today as the Yonaguni Monument. It also goes by the name of Japan's Atlantis. The entire monument is about the size of 5 soccer fields and the height of a 5-story building. Its most surprising feature is its expanse of terraces. Explorers and scientists believe that Yonaguni might be 10,000 years old. But whether it's a human-made structure or a natural formation is still under debate. For Japan's top marine geologist, Professor Masaki Kimura, Yonaguni is the heritage of a lost civilization. Kimura has dived to the bottom of the ocean to explore the ruins over 100 times over the past 10 years. According to him, there are clear signs of human activity down there. On the monument's surface, there is a triangle-shaped concave that is a historical symbol of water fountains in the region. There's also a giant turtle carved on the eastern side of the structure. And, according to Kimura, turtles have an important cultural meaning. Several pieces of stone tools have been recovered from the site. Their estimated age is around 10,000 years. However, not all scientists support this theory. For many, Yonaguni is the result of thousands of years of erosion. The fact that the monument is composed of one massive rock leads them to believe it's not human-made. The defined edges and flat surfaces resemble a natural formation in Northern Ireland, known as the Giant's Causeway. The basalt columns look like the ruins of a palace, but they're actually the result of volcanic activity in the region. Now, you're flying to the coast of Greece, 4 hours away from Athens. More specifically, You're in the Peloponnese Peninsula. You dust off an old snorkel and head for a free dive on a bright sunny day. Sometime into the dive, you start noticing patterns on a seabed. 13 feet below the surface, outlines of familiar objects start to appear, one by one. As you continue swimming, what looks like the outline of an entire city emerges in front of your eyes. Are you wondering how water could have taken the whole city? Rocks are perfectly aligned into what appears to be the foundation of a building. This is Pavlopetri, an ancient city you've probably heard about for the first time. It was discovered by Nicholas Fleming, a British oceanographer, when he was on vacation in Greece. He had heard rumors about Pavlopetri's existence and indeed found several artifacts on the seafloor. He went back to the area a year later with the team. They found a site filled with pots, storage vessels, and tools. A kernstone, for instance, is a tool used for grinding grains and turning them into flour. Multiple amphoras indicate that this settlement dates back to the Bronze Age, 5,500 years ago, when people started living in towns. The settlement is believed to have existed for over 2,400 years. Today, Pavlopetri is considered the oldest submerged town ever discovered, and what's impressive is that it wasn't a simple village. It was a vibrant port city with stone buildings, a marketplace, streets, and even squares. The next stop on our voyage is one of today's most famous underwater cities that has been turned into an archaeological park. The city of Port Royal in Jamaica exists only below the surface, but in 1692 it was one of the wealthiest cities in the Western Hemisphere. Port Royal was the center of the British Empire at the time and an important trade city that attracted people from all over the region. It was also home to real-life pirates of the Caribbean. On the morning of June 7, 1692, the people of Port Royal met a different fate than they had probably expected. The city woke up shaking. People were thrown out of their beds by the power of a massive earthquake, ranking 7.5 on a Richter scale. One survivor said he had seen Earth opening up and swallowing the whole town. What he said could be true, as the city was mainly built on sand. The ground swallowed buildings, roads, you name it. Geysers erupted, and finally, waves as big as 10-story buildings hit the city. About 33 acres of the city disappeared under the water. Amazingly, most of its 17th century remains are still in good condition under 40 feet of water. Archaeologists have found taverns, storage rooms, kitchens, and recreational buildings used for diverse purposes. You can also see a grand lion statue, a submerged bridge, and many picturesque arches. Of course, I saved the best for last: India. Just off its coast lies another sunken marvel. A site known as the Lost City of Cambay is located in the Gulf with a similar name. It remained undiscovered until 2001, when the National Institute of Ocean Technology made a routine water assessment. With the help of sonar technology, which sends a wave sound to the bottom of the sea, they found something far beneath the surface. Images showed well-defined geometric shapes spread along a 5-mile stretch. The remains date to more than 9,500 years ago, meaning this civilization was lost at around the end of the Ice Age. Debris recovered from the site included construction material, pottery, beads, sculptures, and even bones. Scientists argue whether these artifacts are indeed from the site, but if they truly are, then the lost city of Cambay might be the oldest civilization in the world.